here's an updated calendar for you. I've gone through and I've changed some of the dates. The assignments are also the same. I've just changed the dates as to when they occur. So as you'll notice, today we had kind of a review 5.3 homework day. So now you're watching the 5.4 video, so that takes care of the second. So tomorrow in class you'll be working on this homework, then we'll have a review worksheet, so your quiz will be on Friday, and then over the weekend you'll watch the 5.5 video. We'll review that a couple of days next week, move into 5.6 and 5.7, and then there before Christmas, just before Christmas, actually probably I put in the dates, down there it'll be the 17th, and on the 18th, which is the second to last day before Christmas, we'll actually have that Chapter 5 test. So we're still fine to have everything done before Christmas break. We won't have to push any of this till afterwards, which is good. We're still on track. We're still actually a little earlier than I've been in past classes. So no need to worry there. We've had the few days to work with, like I told you guys before. We're just kind of rearranging things a little bit. So make sure you copy this down, print it out, whatever you need to do, to make sure you have some of those dates and things changed on your calendars. Alright, today we are on to 5.4, which is complex numbers. Complex numbers are imaginary numbers, which deals with the letter I. So a lot of you have seen or heard about that letter I, and you kind of asked when we're going to get to it. So here is when we start with that the complex notation in the imaginary numbers. So we're going to start with some definitions. Square roots, you guys have dealt with square roots before. A square root is just any real number for which if a squared is equal to b, then a is the square root of b. It just means that any two numbers multiply, you're getting the original number that you can multiply by itself to get a number. The product property of square roots just says that when you get the square root of AB, you get the square root of A times the square root of B. You can separate that product into two separate square roots. Same thing for quotient. If you're taking the square root of A divided by B, you can separate those into the square root of A divided by the square root of B. So you can separate those out as well. And you can go back and forth. If you have the square root of A times the square root of B, you can make it the square root of A times B. And if you have the square root of A divided by the square root of B, then you can make it the square root of A divided by B. So you can go both ways with that. So they just want us to take a look here and to simplify some of these. So if we're looking at the square root of 50, what we want to do is rewrite this so that we have perfect squares that I can actually get the square root of. So I'm going to rewrite this as the square root of 25 times 2. Because 25 is a perfect square, 2 is not. So the square root, using my properties, is the square root of 25 times the square root of 2. Well, the square root of 5 is 5, and then I have to leave that as the square root of 2. Do not give me the decimal format of that. Leave it in this format. This format is what we call simplest radical form. Same thing for the quotients. If I separate this, I can do the square root of 11 over the square root of 49. Well, 49 is already a perfect square. So it's the square root of 11 over 7. In that simplest radical form. Square root of 45, we're looking for two numbers that multiply to give us 45, so that one of them is a perfect square. Well, that would be 9 times 5. The square root of 9 is a perfect square. Square root of 9 times the square root of 5. Square root of 9 is 3 times the square root of 5. And that again is the simplest radical form. So that's the only goal there with those properties, is we're just trying to get it to the point where we can rewrite them so that we have whatever out of the radical that we can take, and then everything else is left inside. Taking a look at some more definitions, here's where we get into that imaginary unit. So the imaginary number I is the square root of a negative 1. Because if you guys have heard me say before, we cannot take the square root of a negative number. So by using the letter I, essentially it allows us to factor out that negative so that we just represent it with I, and then everything else is just like normal. And the pure imaginary number is square roots of negative real numbers. That's what we're going to take a look at now. So if we have the square root of negative 18 and want to simplify, the first thing we're going to do here is take out that negative number. So we have the square root of negative 1 times the square root of... Now how can we divide up 18 so that it has a perfect square factor? 9 times 2. So we get 9 times 2, so the square root of a negative 1 times the square root of 9 times the square root of 2 Well, this is I and this is 3. So we're going to have 3I square root of 2. And that would be your final answer there. When we have variables, you want to make sure that the variable has an even exponent or is divisible by whatever root you're taking. So we're taking the square root, so we want to make sure it has an even exponent, so it's divisible by 2. So again, we're going to factor out that negative 1 times 125 can be divided up into 25 times 5. And then x, I'm going to separate it out into x to the 4th times x. So that way x to the 4th is a perfect square, and I'm leaving all the leftovers. Same thing we did here. Perfect square, leave all the leftovers. Perfect square, leave all the leftovers. So this is the letter I. Square root of 25 is 5. Square root of x to the 4th is x squared. Then we're left with the square root of 5 and x on the inside. Now let's rewrite this to make it a little cleaner. So we're going to have 5x squared. I is typically the last thing you write. It's just like a variable. You attach it on just like everything else, but normally you put everything else in front of it, and then the radical, whatever's left. So it doesn't look very pretty, but that is actually the simplified version of what they gave us. Then we have the square root of negative 27. So the square root of negative 1 times 9 times 3. So square root of negative 1 is I. Square root of 9 is 3. And then we're left with the square root of 3. So we have 3I square root of 3. And that's what we're doing. So I doesn't really change anything from what we had done before. We're just having to factor out that negative 1 first. And if there is a negative, write it in terms of I. But you never want to leave the negative underneath here. If there's a negative there, you have to write the I out front and get rid of that negative number. Now, let's go backwards the other direction. If they give us things in terms of I, they want us to simplify them. So if I have negative 2I times 7I, it's just like variables. Negative 2 times 7 is negative 14. I times I is I squared. But when I multiply this, I squared is really just saying is equal to the square root of a negative 1 squared. Remember, the square root and the square is going to go away, so we're just left with negative 1. So whenever you have an I squared, that's really just a negative 1. So you don't want to leave it I squared, you want to change it to a negative 1 and rewrite this so it's a final answer of 14. Now with square roots, you don't want to multiply these and get rid of the negatives, so it's going to eliminate the I that really should have been there. So what we do is we say this is I square root of 10 times I square root of 15, and we get I squared square root of 150. Because separated, there are no factors here that are perfect squares. But a factor of 150 is 25. So now the I squared out front is now just a negative 1 square root of 25 times 6. So I'm actually going to get a negative 1 times 5 square root of 6, which will give me negative 5 square root of 6 for my final answer. Now when I have I to the 45th, that means we're taking I 45 times and multiplying it. However, if I go through this, so I is the square root of a negative 1. I squared is negative 1. I cubed is a negative I, because that's equal to a negative square root of a negative 1, because you would have had I squared times I to the 4th is going to be I squared times I squared, which is -1 times -1, which is just 1. So what we're doing is we're saying, what's a multiple of 4 that goes into 45? Well, that would be 44. Because this is going to repeat every 4 times. Now, I to the 5th goes back to what I was. I to the 6th would be what I squared was. 7th would be I to the 3rd, and 8th would be I to the 4th. It repeats every 4 times. So I'm going to say, what's the next least multiple of 4? Well, that would be I to the 44th. That's going to be just 1, because that's a multiple of 4. But I'm still left with one more I to make that 45. So this is 1 times I, and I just get I. However, here, the multiple of 4 that's less than 31 is 28. So I have I to the 28th. Well, how many do I have left? I have 3 of them left. This is 1. Well, I cubed is -I. So we're left with just -I. So these aren't necessarily intuitive, but really what you're asking yourself is, what's the multiple of 4 that's less than this number, and how many do I have left after that multiple? So here it was 28, we had 3 left over, so I go down to the third thing. So you want to make sure you have this piece copied down in your notes, so you can reference that, so you know, okay, if I'm on the 2nd, I have -1. If I'm on the 4th, I have 1. If I'm on the 3rd, I have -I. So on and so forth. Alright, the square root property. A few more notes here. Square root property says for any real number n, if n squared is equal to n, or excuse me, if x squared is equal to n, then x is equal to plus or minus the square root of that number. Because remember, if I take -5 squared, that's 25. If I take 5 squared, that's also 25. So technically, when we're solving for a variable, we don't know if we're looking at the positive or negative version of that number. So we have to take both into account. So when you solve for the square root, we're going to look at both the positive and negative version of that number. And so here they're asking us to solve for 3x squared plus 48. And so we want to look at solving this just like normal. So we want to get x by itself. So we're going to subtract 48 from both sides. So we have 3x squared is equal to a -48. Divide by 3. X squared is equal to a -16. Well, to solve for x, I have to take the square root. The square root of x squared, square root of -16. I just took the square root of a negative number. What's going to be involved? I is going to be involved. So I have x, but that's going to equal plus or minus, because it could be +4 or -4. I have to include the I. So it's going to be plus or minus 4i. And that's your answer. Let's try again. 4x squared plus 100. Again, get x by itself. Subtract 100. $4x squared is equal to -100. So we divide by 4. X squared is equal to -25. Again, when I take the square root, we have to use the positive and negative version. So we have plus or minus. Square root of 25 is 5. I had a negative, so I have to include the I. So it's plus or minus 5i. And that's all that's to it. We're doing it just like normal, except now if we have a negative square root, we have to incorporate the I, and we're also including both the positive and the negative versions of those answers. Instead of just 4 or just 5, it's positive -4, positive -5. Complex numbers. A complex number is a number that adds and subtracts both imaginary and real numbers. So 5 plus I would be complex, because 5 is real, I is imaginary, and I'm adding the two of those things together. So it's written in the form a plus bi. A is a real number, just like we've always been using, and bi is an imaginary number because it has that I attached to it. So we're looking at solving these. When we add and subtract these, they are exactly the same as adding and subtracting like numbers with x's. So what we're going to do, we're going to have 2x minus 3 plus, I'm going to distribute, or excuse me, we're going to leave it. If you look, if I group this together, this is a real number, this is the imaginary number. So that means 2x minus 3 has to be equal to 3. And then y minus 4 has to be equal to 2. Because this is the number that's in front of the I, which means it has to be the same as the one over here. So if I subtract it, or if I add over here, 2x is equal to 6. So I divide by 2. X is equal to 3. Over here, when I add 4, y is equal to 6. So x equals 3 and y equals 6 are the values that are going to make that the same. Same thing down here. We have this group together, gives us this piece grouped together. Then this is the piece in front of the I, and this is the piece in front of the I. So we want to solve each of those separate equations. So we have 5x plus 1 is equal to 2x minus 2. 3 plus 2y is equal to y minus 6. Subtract 2x from both sides. 3x plus 1 is equal to negative 2. We subtract 1. So we get 3x is equal to negative 3. X is equal to a negative 1. Over here I'm going to subtract y from both sides. So we get 3 plus y is equal to negative 6. Subtract 3. Y is equal to a negative 9. So nothing more there, just recognizing which pieces match up with what. So you have all the real things should be equal to one another on both sides, and all the things in front of the I should be equal to one another on both sides. Now here's where we're adding and subtracting complex numbers. This is where it's like adding and subtracting like values. So just like we've added and subtracted x's in the past, we're doing the same thing with the i's. So here I have 6 minus 4i plus 1 plus 3i. Well, I have 6 and 1 are the same. Then I have negative 4i and 3i. 6 plus 1 is 7. Negative 4i plus 3i is negative I. And that's my final answer. Over here, distribute the negative. So we have 3 minus 2i minus 5 plus 4i. So we have 3 minus 5 is negative 2. Negative 2i plus 4i is plus 2i. So negative 2 plus 2i is our final answer. Again, negative 2, I'm just going to rewrite it without the parentheses. So negative 2 plus 5i plus 1 minus 7i. So negative 2 plus 1 is negative 1. 5i minus 7i is minus 2i. And the last one, again, distribute that negative so we don't forget about it. So we have 4 plus 6i plus 1 minus 2i. So we have 4 plus 1 is 5. 6i minus 2i is 4i. So you should always end up with one number that has I and one number that does not. So you can keep simplifying until you get down to that. When you have i's in the denominator, we have to use something called the complex conjugate. The complex conjugate is not that tough. We just have to take some getting used to. So what we're doing here is we're going to multiply whatever the denominator is. I'm going to change the sign, just the middle sign. So I'm going to make it 2 minus 4i over 2 minus 4i. Because I have to multiply by 1. I can't change the value of this, so I can't multiply by anything other than 1. So because this is something over itself, it's 1, but it's the complex conjugate of this. So I'm going to distribute. So I have 3i times 2 is 6i. 3i times negative 4i is negative 12i squared. All over, I'm going to FOIL this. So 2 times 2 is 4. 4i times 2 is plus 8i. Negative 4i times 2 is negative 8i. And 4i times 9 is 4i is negative 16i squared. These cancel. 6i. Negative 12 times negative 1. All over 4 minus 16 times negative 1. Notice what we did. We eliminated the i's in the denominator. That's our goal. We eliminated the i's in the denominator. So in the numerator, I now have 12 plus 6i. In the denominator, I just have 20. I can reduce all of these by dividing by 2. So we have 6 plus 3i all over 10. And that would be my final answer. Now here when I'm just trying to get rid of the I can just multiply by I over I. Because I times I is I squared. So up on the top I'll have 5i plus I squared all over 2i squared. Well, the I squareds turn to negative 1s. So we have 5i minus 1 all over 2 times negative 1. So that's negative 1 plus 5i all over negative 2. So this last one, again, look at the denominator, change the sign, and put that on top and bottom. Make sure you change the sign. A lot of students forget to change that sign. You have to change the sign. Distribute. Negative 6i plus 10i squared. FOIL. We have 9 plus 15i minus 15i minus 25i squared. In the numerator, we have negative 6i. That changes it to a negative 10. All over, these cancel. We have 9. That changes it to plus 25. So that's going to be a negative 10 minus 6i all over 34. Divide it all by 2. Get negative 5 minus 3i all over 17. And that's our final answer. And that completes our lesson. So there's your homework. It's page 264, 22 through 38, and 42 through 49. So make sure you have your books and things in class. We'll go over any questions or things you guys may have tomorrow in class.